Welcome to chapter number 5. Here we are going to see software development lifecycle, which is also called as SDLC. Purposely it is mentioned in the bracket system because software can mislead you that only coding part we are looking at, but actually when project is there, it is the entire system development. So we are talking about not only the software aspect, but the hardware, many other interfacing devices, networking, everything we have to think as a total as a system. So when you are developing any project, it consider all those elements. That is why it is specifically mentioned in the bracket as a system. Well, this SDLC cycle is well defined as per the ISO IEC 12207. This is the international standard. ISO means International Standard Organization, and IEC means International Electrotechnical Commission. So it is internationally recognized process or methodology which is well defined, and internationally all companies following in their software development processes, I mean projects. So that is what we have to understand, and it is something which is standard, which is followed, and it is aimed for what? To produce high quality software that meets customer satisfaction or expectation, and it will maintain the timelines and cost estimation. So all those aspects being taken into consideration. So normally there are 6 phases of these life cycles. Which are those? Here we can see it is starting from analysis. So requirement analysis is very first important stage where all the scope of the project, which we saw in the chapter number 3, I think, scope and requirement analysis, which is covered in the phase 1. Once the scope and requirements are very much clear and freeze, then we'll go for design stage. UI UX, you forget about it. This is UI UX is user experience, user interface, which may be the part of the design, but not in totality. So design in general we can say. Then we have implementation fully, partially, phase wise, so that one can check and then improvise and recheck. Like that, the testing will be followed by implementation, and it is maybe sometime it is repeated within this 3 and 4. Then it will go for the deployment. Once the things are more or less working fine as per the requirement, then it will go for deployment, and the deployment also can be a phase manner. And once it is deployed and the project closure is there, but the maintenance part will retain, because there will be continuous requirement for development, for new additions, so new initiatives, maybe business requirements are changing, so all those has to be accepted into that project. So we have to go on keeping the maintenance cycle. But even though when it is a maintenance, the new requirement will undergo the same cycle. It is not that it will stop there. It is a loop. That is what is called cycle. So that is the fundamental understanding, is a development cycle. Now we are going. So in SDLC cycle, there are various activities which define different processes. So obviously it starts from requirement analysis. So system requirement, software requirement, then we'll go for design. So it is process that we have to implement. Every analysis followed by process, followed by design, followed by testing, and then followed by acceptance support. So all this is continuous activity which is undergoing as a phase manner within a SDLC cycle. So that is what is called list of activities which are majorly happening throughout the SDLC cycle. So many time it is in continuous loop. So it depends on what type of model we are going to follow. So next we are going to understand there are different types of model people come out with for SDLC implementation. So next slide will talk about the model. The very first model we are looking at is waterfall model. It is classical life cycle, and it is very old model rather, and it was okay for the less complex type of project. What you understand from the figure is, rather than it is a cycle, it is open loop thing. It is not closed loop. It goes from the requirement to maintenance in the similar fashion as it is defined in SDLC life cycle, but it is a waterfall because it is like requirement you finish, then you go for design, You finish design, then go for development, testing, deployment, maintenance. So it is a straight flow, like water falling from waterfall, right? So that is what it is mentioned, but this is not practicable in the latest type of things, where we have such a complexity and system integration is very, very complex. We can't have this type of straightforward thing, but still people are using in small project. So first we will understand what are the advantages of this model and what are the drawbacks. Advantage is obviously it is simple, easy to use, model is straightforward, okay, but it follows the structural approach, highly structured model. So everything we have to structure in phase, every phase is has to be well defined and completed before we move on to the next phase. That is what is the main constraint that we have to follow. There are clear milestones because every phase is ending with the milestone, so deliverables are clear, okay, well documented. We can document it because it is straightforward. It is going from 1 2 3 4, so straightforward documentation we have to follow, well documented. Easy to manage, again it is straightforward. Linear nature, so it is linear nature. The waterfall model is easier to manage, especially in small project with well defined requirements. Early detection of deficiency, problems are identified early, so that is why the life cycle become to the through documentation. Review process is much easy in this case. So these are some advantages. What are the drawbacks? There are drawbacks. Not flexible, inflexible. Model is handle any new requirement, new changes. Agility we call it as a dynamic thing. Once it is not that we can accept that changes. So once the phase is complete, it is difficult to go back. So it is some sort of static things or rigid things. So we can't move to and fro sort of thing. So that is the constraint of it. Late testing, so testing happens at the very further stages, so there is a big problem because once you identify any defects in the testing phase, you can't go back again design. This can leads to the late discovery of major issues, right? Assume stable requirements. See, this type of model consider that requirement is 101% going to be freeze and no alteration will be possible, but that is not the always practically possible. Most of the time the requirements and some constraints we have to take into consideration, we have to modify the things, so that is not absorbed in this type of model. The risk of high cost and delays, limited customer involvement, because customer involvement not be there, limited only at the time of testing maybe or deployment phases it will come into picture, or requirement analysis obviously. Poor suitability for complex and long term project, this is big problem. So we can't accept this model when our project scale up to the very large type of things, and complexity of the project is also very, very high. So that is the one drawback. So whatever the drawbacks we observed in case of waterfall model, which will be taken care by this prototype type of new modeling concept. So prototyping means like actually developing the finished product. We develop a small demo version of it or prototype of it. So here you can see that basically what we are trying to do, we are going to have this type of to and fro approach, where we are going to make a prototype, develop refined prototype, and we'll give it to people who are going to use it for testing, okay, by the customer. So by customer they are going to use it, test it, and check it whether any drawbacks are there or some shortcomings are there. So that will be your feedback, and that feedback is again taken into consideration for further development or refinements, we can say refinement. So that is what is called prototyping. So it is going from requirement analysis, design, this is the same thing which is SDLC, software development cycle, but now here we are going to have intermediate stage. In this stage, design deployment development stage, we are going to follow this particular type of triangular operations which help us to refine the actual project at early stage, so that we will not suffer in terms of quality testing at a later stage. And especially for complex project, this is very, very important, because prototype will give us the actual feel of the outcome, and it will give the any drawbacks at the early stage. That is why the prototype is very popular thing. Here is a list of advantages of software prototyping. Compared to the previous models, here we can see the major advantages in terms of user involvement and feedback. So customer or end user is directly in the part of the process of development. So that improves the total outcomes. So involvement ensure that the final product meets the user needs and expectation more accurately. This is very vital. Then clarify the requirement. So when the user start using it, many times the things are not clear to the end user also at the initial step, but once they start looking at the prototype of it, they understand what they was looking for and what actually happening. So accordingly they can give the feedback, and any misunderstandings or overlooks can be taken care by. This is again very important aspect. Early detection of issues. So again, potential problems can be identified, addressed at the early stage. So it will cost us less in terms of time, in terms of efforts. So that is also good. Then enhanced communication, since it is a visual and functional enhanced communication, means we can see real things happening, outcome. It is not hypothetical things, which prototype will give you the real feel of it. That is why user also can understand how it is going to be, and it can give the real feedback, which help us or developers for absorbing the things very nicely. That is again a very great advantage in terms of prototyping. There are few more advantages. Reduce development time can cause, increase flexibility, so it can absorb new requirements. Risk management is also very important aspect. So rather than going into final stage and then understanding the issues, it will be very risky affair. But rather than at intermediate stage, if you can find the issues, we can taken care at very less efforts, and it is less risky. Better design decisions, user trainings and acceptance, because user is directly involved in the prototyping, so he can learn and he get trained simultaneously when the project is under progress. Stakeholders buy-in, working prototype can secure. So stakeholders also can, all the stakeholders, not only end user, but all the stakeholders of the project also get the feel of the project, and they can monitor or they can really see the things how it is going as a progress. Next model is a V-shaped model. This is a very interesting model and rather useful model too. Here you feel there are a lot of blocks which are interconnected, and they are inter feedback type of things are connected from one block to another block. But primarily you can say there are three layers. One is unit testing, integration testing, and system testing. So you can see coding is the development part. So coding will happen at the modular level or the unit level. So every unit first undergo detailed design, the detailed design and coding. See, you can see the incoming arrow and outgoing arrow. So design and coding will go in sync. Once it is done, other side of it, it will go for unit level testing. So one design is there, it is implemented through coding, and that once the code is ready, we have to do at the unit level. Only that part, only that functionality, only that modular level, we will check it whether it is working fine. So that is why it is called unit test plan. Then there will be multiple units, right? So one team develop one model, next team develop another model. Now we'll plug in two models to see the how they are interfacing with each other and how they are working in sync, whether they are having some problem when we integrate them together. See, independently every unit is working fine, but when we interface with one unit to the next unit, and we are expecting the output from the next unit which is not meeting the requirement, then there is some issues within the two interfaces. It is not particularly unit level but at the interface level. That is why people do integration testing. And finally it is a system level testing. So when different modules are developed, so basic unit, number of basic unit constitute a modules, number of module constitute the systems. So we can undergo final requirements. So system level requirements we can verify at the system testing level. So this is the how the different levels through which it works. Now, why V shape is there, that is clear with the next slide. See, this is how it is look like a V shape. So there is something called verification phase and validation phase. So see, one verification is going into the coding, and from coding we are performing testing, right? So developer life cycle and tester life cycle, these are two different personalities which are coming into picture, or different teams we can say, developer and the testers. Tester doesn't get into the code part of it. For them, code is a black box. Though they are not the part of the development, but the coder know the coding, so they do the coding. They actually write the code as per the design, as per the specification. So how design is being phrased? From the specification, business level specification, system level specification, high level design first it will be there, then low level design will be there. So at the modular level, high level means at the modular level, and then low level means unit level. So everything will be verified in this case, then it will go to the coding. And what is here mentioned here at this every stage, this is what is the testing perform at every level. When it goes from coding, it propagate like this, and then there will be cross testing with respect to verification, so that is called validation. So once verified, this is verifying the requirements and design, and here we are validating those what is implemented through code at unit level, component level, system level, and acceptance level. That is gross level, or we can say complete system level. So that is why the journey is like V shape. You can see here, and that is why it is called V shape model. Understood? V-shape model is found to be very practical type of thing, which are very widely accepted and used in most of the projects, which may be complex type especially. So there are a lot of advantages which are listed here in this slide. I need not to go and read these things. I don't want to spend time on this because it is self-explanatory. So you can just go through the pointers and you will understand how it is more advantageous overall. But there are some drawbacks. Again, there is a flexibility issue, means we can't accept the new things. It is not so dynamic, somewhat rigid. Okay. Again, it assumes like a waterfall model, some stable requirements, assuming that the things which are already freeze and it's not going to change. That is the assumption in this case also. Let software delivery, high risk uncertainty, limited custom involvement, and overhead cost is there because a lot of testing is involved. So it will be a rigorous testing phases will involve a lot of tester teams as well as developer team. There are two different teams we required, and that will cost us overhead. So that is again a drawback. So you can go through the pointers and explanation and very well explained in book. We will go ahead with the next model, which is called spiral model. So spiral nature, you can see from the figure, it is going from the innermost layer to expanding, and ultimately is achieving the real shape of it. So you can see there are four different quadrants: planning quadrant, risk analysis, engineering, evaluation. So initial requirements, it starts from initial requirement, even risk analysis. So in planning stage, requirement is there based on customer comments. So see, requirement goes on changing as per the customer feedback in the planning stage, and it goes on expanding. So the spiral nature of the things will bring in the dynamic things in the phase of development. That is why this model is more sort of agile nature. Okay. So initial prototyping is also there. Next level of prototyping is there. As the system expand, the prototyping will play vital role of giving feedback and further improvisation. So customer evaluation is a part of it. So these quadrants and the design, engineering is mainly involved with the development and design, right? So this is how it goes. So this spiral nature is phase manner. We are actually following the SDLC cycle in repeated manner with the expanded nature. So we are initially start with the basic requirement, then we go into the more depth of the requirement, in further depth of the requirement, and you are like you are going through the abstract way and fine tuning this thing to the more perfection or final fulfillments. That is the whole concept of spiral model. Again, there are different advantages, disadvantages associated with the spiral model. I'm not spending time on this because these are self-explanatory through the text, and these are just pointers and their explanations are very well given in the book. Scalability, I wanted to emphasize on scalability, because scalability, as you go against big projects and complex projects, the scalability is not clear at the initial stage, but as you implement it, you realize the scope and the scalability of this may be expanding. Disadvantage is of course complex. It is very complex, not straightforward. Implementation point of view, high costs because many team members are involved, in terms of uh, time as well as the infrastructure or the resources we have to harness to perform the things. So all this will cost us. So these are the disadvantages spiral model. I will mainly discuss about the model construction rather than advantage and disadvantage, because these are all self-explanatory. Next model is iterative or incremental model. Now, why it is called iterative? Because we are having some iteration 1, iteration 2. So there is something called some fixed number of processes which are there and it is being repeated, right? So iteration 1 also got analysis, design, implementation, testing. Iteration 2 got analysis, design, implementation, testing, and so on. So there will be n number of iterations. Iteration 1, 2, 3, 4, and so on. But every iteration consists of these 4 activities. So it is, we can say, like going from one level of abstraction to the next level of abstraction, and it is slowly shaping up. The project is shaping into the final achievements or final requirements through the phases, or we can say incremental phases. Or these phases are nothing but the iterations. So that is why it is called incremental iteration. So once you finish this iteration, it will again go into analysis, design, implementation, testing. So second phase is over, or second iteration is over. Next it go again analysis, design, implementation. So these things are goes on repetitive. So that is, it may finish after fifth iteration, it may finish in after 10th iteration. It depends on the complexity of the project, scope of the project, all those things. So this is also very useful type of model which are being used by industries for software development. Again, we have to look into the advantage and disadvantages. So obviously is flexible and adaptable. So adaptability is a great advantage here. So we go on accepting because iterations are there. So new requirement, you go on accepting a different level of iterations. So early product delivery, continuous improvement, risk management, these are very important aspects which possible in this type of model. Again, there are user feedbacks. So because it is iterative, at every stage we get a feedback and improvise, because testing is there in every phase, every iteration. Okay, you can even allocate the resources nicely because we understand the requirements are changing at every iteration and how you have to manage it with. Quality also improves because we develop process, and every iteration some improvisation is there, so quality wise it is good. So these are advantages. Of course, there are disadvantages. More complex planning because these iterations, n number of iterations we have to plan and repeat. Integration is also challenging because every iteration produces some output and we have to integrate with the next output, next iteration. So there will be a modular approach. We can say one iteration produce some module and that we have to plug with the next module, and it go on expanding. The module is going to be expanded with the integration, and every iteration lead to the new integration, and then finally the complete system is developed. So it is somewhat complex. So that is what is disadvantage. So there are other disadvantages which are self-explanatory. You can go through it. I am not spending time on it. Mainly I will explain the models again. Well, next model we are discussing is rational unified process, which is more professional level type of model, evolve at the higher complex level projects, where we can see there are 4 distinct phases: inception, elaboration, construction, and transition. And you can see there is to and fro, go, no go, sort of things. And there will be life cycle objectives within each phase. Life cycle architecture, you can say initial operational capabilities. So as you move from inception to elaboration, elaboration to construction, and construction to transition. And we'll see each phase in detail in next consecutive slides. So what happening in initial inception phase? It takes about 10% of the efforts, emphasizing gaining an idea, vision of the product, hence done just once on the project. So it is like scope and requirement analysis, which is initial phase. Preliminary sequence in non-iterative, it is initial requirement, so it is not going to be repetitive much. So once the requirement are freeze, then only we are moving ahead. Rough estimation of the cost and resources also done in this phase, inception phase. Once the scope is well defined, important risks are identified and prioritized. All this is done in this phase. Planning for the elaboration phase is also done. So this is what 10% efforts will take in inception phase. So we can say initial phase or inception phase. Elaboration take next about 20% of the efforts. So we come out with the elaboration in the sense more detailing. So it is like use cases are defined in this case. So developers start working on the requirement, uh, develop a use case, test case, and start designing it, and interactions, then coding. All this come under this thing. The software architecture is designed, generated, system level design also carried out. So this phase is very happening or very acting. A lot of efforts are there. Most requirements are considered, and implementation and testing will be a part of this elaboration. Construction phase is rather most active phase, which is consuming rather most thing, where the systems are built and the series of iterations are performed. So previous model, what we saw, the iteration, incremental nature. So this is what is a part of this phase. So this particular model is a further evolution of the previous incremental model, which we discussed in the previous slides. Okay, so here what happening, those incremental and iterative processes of requirement, design, implementation, testing, which is happening in this construction phase, right? So it is obviously consuming the major efforts of the entire development cycle. Then comes the transition phase, which is equivalent to implementation, deployment, maintenance, because here the things are already under use by users, and they give some feedback, and accordingly you have to make some changes. So that is the final transition stage. So this is how it works. Obviously advantage is iterative development, so we are more flexible, we absorb the changes, we absorb the constraints or the user feedbacks very nicely. Even we can handle the issues very nicely, and this is obvious advantage because it is going the inception level to development and construction, which is again iterative type. So that is why we can absorb the changes very nicely, and risk handling also easy. So that is the advantage. We can have more requirement management, clear documentation. So these are all advantages. So we can go through this. Quality aspect also nicely handled, because we are moving from iteration to iteration. Reusability is also very important. Scalability is important. Structural approach. So this help us, and component based architecture, which may build the unit level to the component level and then system level. So that approach is there. So consistency and clarity is also very important. So these are all advantages we can read through. Of course, the complexity is a disadvantage. Uh, so RPU comprehensive and detailed nature can be complex and difficult to learn for new users. Okay, so the complexity of the project is also there, and the model is also very complex because it is going through the multiple phases. Resource intensive, you require more time and efforts. Cost, obviously, because cost is directly proportional to the efforts and time. So that is why it is costly affair. But complex projects has to have this type of phases and iterations to conduct the real to handle the complexity. Well, these are some drawbacks also. So customer needs not one size fit to all. So we can't have something which is very freeze. Some customers, suppose we develop some model or some project for some pro customer. So client to client, the requirements has to be changing. So we have to absorb those changes, which become more challenging. Okay, then there may be some rigidity because system is well structured and formal. So we follow some bureaucratic approaches, and it may slow down in decision making because hierarchy we have to follow. We have to go for approvals. We have to for sanctions. So all those process may creep in and may elongate the process of sanctioning, and it may lead to delay. And again, overheads will be proportional to these delays. Dependency of skill power, manpower needs expertise because these complex projects are required more skilled people and even more professional to manage this project. So training requirement is vigorous. So this is what are these are some drawbacks of this type of complex model, and obviously it fulfill the complexity of the development also. So we have to take into this part as a consideration. Well, coming to the next model, which is agile development model, which is more common and industry prefer this type of things, especially with the new types of software projects or new approaches to absorb the technology, which is always dynamic, evolving. So in that sense, it is more agile type of approach which we followed in this type of development. Again, you can see more or less SDLC like there are different phases, starting with phase one, the requirement analysis, concept development is happening in first phase, followed by design, planning. So before design, sorry, there is a planning. So planning means identifying the skill, manpower, testers, developers, project leads, and optimizing it at the planning stage so that in terms of time, in terms of cost, how we can handle the resources. So that is what defined in the planning stage. Then it start collaborative development. So design, development, and testing will go in the third phase continuously, simultaneously, where end users is also involved. So feedback is taken into consideration and the project is evolved continuously. That is why it is agile. Then comes the create and implementation. So frequent development delivery through sprints and feedback on the testing and appropriate changes are impartive. So it is happening continuously. The agileness is because of that, because it is continuous improvisation. And review and monitoring is also part of it, which ensure that the things are moving in proper direction as per the requirement. So this is also continuous cycle, we can see 1 2 3 4 5, but it is more or less mapping with HDLC with some improvisation or agility is brought in because there is a third phase which is continuously taking into consideration the end users involvement. That is why it is called agile. We'll see the advantages, more flexible, adaptable. We can go through this text again. It is very well explained in the text, so I need not to elaborate on this. Okay, you can study this from book. Is all again different pointers for advantages of this type of model. There are obvious some disadvantages also. Less predictable, variable scope, because it is absorbing, it is dynamic, more dynamic, so less predictable. Uncertainties are there, more risks are associated. So we have to absorb those risks. Documentation again a challenge because it's keep on changing. So we have to manage with the documentation. And that is why all this, as you move on to the more complex type of projects or models, the software tools which are used for project management plays very important role, and you have to adapt those in the project management processes. We'll see those tools in the few next slides. Okay, so documentation is challenge, require higher customer involvement. So all these are drawbacks in the agile model. Team dependency, potential scope creep. So as the things are goes on changing, because it is absorbing the flexibility, obviously the scope may expand. Okay, new things will come up and you have to absorb it. So budget may expand accordingly, timeline expand. So all these things are some drawbacks. Now we are looking at some latest type of models which are there, which use different approaches. One is DevOps model, which is like automation type of thing. more integrated in terms of software development and RT operation, which goes hand in hand. So the things can be developed faster with uh, lesser resources, and it can be done parallelly or continuously. And automation bring in the speed of development and deployment. Both can be development, deployment goes in sync, so that it will give better results or efficient outcomes. That is why these models are used nowadays, DevOps type. Next is lean software development. Lean is a concept which comes from the manufacturing industry, to minimize the waste of resources. So optimizing the or more efficiently utilizing the resources, so that uh, we can have cost effective or more time effective optimizing the things. So it empowers to decision making, so that team level we can have more decision making, and it can enhance the time effectiveness and minimize the waste. That is the idea of lean software development. Next is the feature driven development. Here again it is iterative incremental type of development, which we already discussed in the previous model. One of the model was incremental and iterative. Only thing, it is more feature based. So features we are go on adding. So we are building the features. Overall models are built upon the features. We keep on, just like mobile, we are coming with the new features with the new models. Same way, the approach is something like that. So planning for new feature, design for new feature, building on the feature. So it is a feature driven. So your software development, the things are evolving, new features we are adapting, and that is why it is called FDD, or feature driven development. Next slide, we are looking at the life cycle processes. See, we have studied the models which are mapped with the SDLC. Now we are discussing more on the process level, not the phase manner, but the which are the processes involved in different phases. So international standards group the activities that may be performed during the life cycle of software. So process is a number of activities which are associated with the respective phases. The 5 primary processes which are there: the acquisition process, supply process, development process, operation process, and maintenance process. So process is associated with respect to the respective phases. So acquisition process is something like the requirement analysis, which are we are acquiring, right? And then we are going for the development. We are supply means supply manpower, supply of resources, all those things are also part of the processes, which is come under primary processes. Then development process, which is obvious when we go for the implementation, coding, testing, all those is a part of the development process. Operation process, when we deploy it, so end user training, their feedback, and then improvisation, testing, all this again a part of the operation process. And maintenance is obvious, when the project is under implication, when the things are being under use, there will be some issues which we have to take care. That is what goes under maintenance process. Then there are 8 supporting processes. Apart from these processes, these are major processes, primary processes. There are supporting processes like documentation, configuration management, quality assurance, verification, validation. This is part of testing, joint review, audit, problems resolution. These are all supporting processes, which is again a part of the cycle, and they are happening along with the major processes. So these are certain things we have to take into consideration when you are going through the project development cycle. Well, now we are talking something at the organizational level, which are the processes. We're not talking about project aspect, but organization, which is handling that project. So there can be management processes, infrastructural processes, improvement processes, training processes. So management process, which is playing the key role in the project, define the basic activities of the management, including the project management itself and related to execution of the entire life cycle, which we have discussed so far. Infrastructure process define the basic activities of establishing the underlying structure of the life cycle. So when the life cycle is going through the different phases, every time some infrastructure is required in terms of space, in terms of resources, electricity, uh, software, hardware, whatever infrastructural requirements that we have to tackle. That is what is infrastructural process. Improvement process, which basically activities that is developer acquiring, that is what perform the establishing and measuring, the controlling and improving. So it is every stage we have to undergo the improvisation. We have to establish the things, certain things. We have to measure it whether it is fulfilling the requirements. We have to control it or improvise it throughout the life cycle of the project. So this is improvisation process, which is part of partial of the life cycle. Training process again, uh, because we have to develop a skill of the developers, testers, as we go through the projects. So part of the activity will be the training, because that is again we required for our developers to get acquainted with the required skill, and then they can perform and develop. So that is why training is also important process. So these are organizational level process which can go through the different projects. Organization handle multiple projects. So multiple projects required these four processes aligned with the respective projects. And then finally, I am coming to the end. These are some tools I have mentioned here, which can play important role, especially in project management, which are software tools to manage the SDLC cycle. GitHub is very important resource, or it is a platform for development of softwares. Many people using very actively GitHub, and many software developers collaboratively doing work here for sharing their sources, source code, and developing, even debugging. And we can have open source sort of thing, where the advantage is there are multiple developers, they can share their skills and ultimately contribute. So this is GitHub. Then there is a Jira, then the linear B, work B. You can go through this. These are some softwares which you can use, software tools rather, uh, mainly to project management of going through the SDLC cycles. Is not directly with respect to the project, but the handling the project or managing the project. There they play the role. Finally, thank you. This is most lengthy type of chapter and required a lot of inputs. That is why I spent some time, even though I tried to sum up the certain things. Thank you very much.